Okay, so how do we simplify radicals? So there's a few different ways you can look at in terms of simplifying radicals. So I'll go over a couple ideas today, and you can kind of decide what works better for you. But if we start here with this first problem, simplifying square root 45, what we're doing here is we are trying to break down the 45, right, into whatever perfect squares we can find, and then we can simplify that out. So one way you can do this is think about perfect square factors. So when I talk about perfect squares, I'm talking about like 1, 4, 9, right? 1 squared, 2 squared, 3 squared. And you want to think which one of those can be divided into 45. And then once you get the perfect squares, we can actually simplify that. So let me actually show you what I'm talking about. So when you look at 45, it's a small enough number, and a lot of us will probably remember that 45 is 9 times 5. So if I'm using my perfect square factors, I can break down the square root of 45 into the square root of 9 times the square root of 5. So now if we go back and remember our radical properties, as long as we're multiplying or dividing, we can separate the square root. And what I mean by that is we can take each of these numbers and put them in their own square roots. If we're adding or subtracting, this doesn't work, but multiplying and dividing, totally okay. And we want to do that because now we can actually simplify the square root of 9, because we know the square root of 9 is 3. So this simplified radical is 3 square root 5. So that's working with our perfect square factors. Now, if you don't remember your perfect square factors, that's okay. Like if you don't remember 9 is a perfect square, it just kind of goes past you because you're going in a rush. You can always do prime factorization. So that could be doing something like making a factor tree or doing some division. So what I can do here is break down the 45, which is the radicand, the number inside the square root or the radical sign. And I'm going to break it all the way down to its prime factors. Remember, prime numbers are things like 2, 3, 5, things that can only be divisible by itself and the number 1. So if I, for example, remember 45 is 9 and 5, but it just slips my mind, excuse me, that 9 is a prime number, I can break 9 down to 3 and 3. And then I have my prime factors. We don't need the 9 because 9 is 3 and 3. So we want to just use the prime factors to rewrite 45. So the square root of 45 is equal to the square root of 3 times 3 times 5. And then if we go back and we think, wait, this is a square root. Squares are 2 of a kind because it's like 1 times 1, 2 times 2, 3 times 3. I want to see how many squares I have. And I have 1 square here, which is 3 times 3. So this turns into the square root of 9 times the square root of 5, which is just going back to what we did earlier. So now I can break this up into the square root of 9 times the square root of 5 to get 3 square root 5. So it totally doesn't matter how you want to break up your problem. What matters is you find those perfect squares and we simplify them out. So one more example here. If we're trying to do the square root of 864, here's where I kind of put in the plug for know your prime factors or know how to do prime factorization, because when the number is this big, you may not know what prime factors or what perfect squares go into it. So I'm looking at 864 and I don't know if I can divide that by 16 or divide it by 4 or divide it by 8 or divide it by, 36. And if you had a calculator, sure, you can guess and check with that. But for me, it's a lot easier just to work with my division because you guys know your division facts. So if we have 864, it's even. All even numbers are divisible by 2. So rather than guessing and checking with those perfect squares, I can just start breaking it down into its prime factors. So this is 2 and 432. 432 is still even, so I can divide it by 2 again to get 216. 216 is still even, so I'm just going to keep dividing by 2. So that's 2 and 108. And by the time I get to 108, I'll realize, hey, well, that's 9 and 12. And then if you want to keep breaking down to prime factors, you totally can, but you might realize, hey, 9 is a perfect square. Maybe I won't break down that 9, so it's kind of up to you. So I'm going to break it down just to get my prime factors. So that's 3 and 3. 12 we know is 2 and 6. 6 is 2 and 3. So then I have 1, 2, 3, 4, 5, 6, 7, 8 prime factors. So what do we do when we have so many of these? Same thing as before. Let's just rewrite the square root of 864 as a product of all its primes. And I like to group them. So going from least to greatest, so I can see how many of the same numbers I have. So I have 1, 2, 3, 4, 5 2s. And then I have 1, 2, 3 3s. Oops, that's a 3. And then what we want to do is go ahead and pair them off. So I have a pair of 2s, a second pair of 2s, and one pair of 3s. So when I rewrite this, 2 times 2 is 4. Then I have another 2 times 2, which is 4. I have a 3 times 3, which is 9. And anything that doesn't get circled, you just put it together at the end. So I'm going to combine the 2 and 3 because they're all lonely by themselves. And I get 6. And then we want to simplify whatever we can. So here, I can break this off in the square root of 4, square root of 4, square root of 9, and square root of 6 to get 2 times 2 times 3 times 6, or what would that be? 12 square root 6. All right. So that is how I simplify square roots.